Hello and welcome to Engineering Simple. So I'll continue talking about limits. This time it's part 2, so the complexity will increase as we go on. So this is just a reminder for the definition of, so limit, basically you find the limit of f of x as x approaches a, so and you try to find it equal to L as a limit. So and notice I said approaches A and not equal A. So that's important because we'll see, it will be obvious in future videos when if you plug in the instead of X, you plug in the value of A, you will get like 0 or something that doesn't, you can't divide by, or and that's where approaches comes from, and again it will be obvious in future videos. So let's start with the first example. So what is the limit of 1 over x as x approaches 1? So as I said in part 1, so the first step is just write 1 over x. Then wherever you see x, you just replace it with 1. So basically it's 1 over 1, which is 1. So that's the solution. So now so what is the limit of 1 over x plus 2 as x approaches 0? So the first step is, again, just write 1 over x plus 2. Then wherever you see x, you just replace it with 0. So this is equal to 1 over, so instead of x, I'm going to write 0 plus 2. So 1 over 0 plus 2 is just 2. So it's 1/2. So basically that's the solution. Now let's go to the next example. So what is the limit of 1 over quantity 2 times x squared plus 2 as x approaches -1? So again, just write the function you're trying to find the limit for. So 1 over 2 times x squared plus 2. So the next step is, so it's 1 over whatever I see x, I'm just going to replace it with -1. So 2 times, so I have x squared, so I'm going to stick -1 squared plus 2. So that's 1 over 2 times, so -1 squared is just 1 plus 2. So 1 over, so 2 times 1 is just 2 plus 2. So it's 1 over 2 plus 2 is just 4. So it's 1/4. So basically the same kind of concept. You plug in the value of, that x is approaching instead of x, and you see if you can get a number that makes sense, So here's another example. So the limit of 1 over -3 times x cubed plus 2 as x approaches 1. So again, let's just write this entire function. So it's -3 x cubed plus 2 Then wherever I see x, I'm just going to replace it with 1. So negative 3 times 1 cubed plus 2. So basically it's 1 over. So negative 3 times 1 cubed is just 1 plus 2. So negative 3 times 1 is just negative 3. And I have plus 2. So it's 1 over. Negative 3 plus 2 is negative 1. And in math, we don't like negative at the denominator. So basically, I will multiply both sides by negative 1. So you have negative 1 times 1 divided by negative 1 times negative 1. So basically, I multiplied by the same quantity. So it's as if I didn't change anything. Times, so negative 1 times 1 is negative 1. Negative 1 times negative 1 is just 1. Negative 1 divided by 1 is just negative 1. So here's another example. So the limit of 5 divided by quantity negative 3 times x to the power of 4 plus 2 as x approaches negative 2. So again, just write the function. So 5 divided by negative 3 times x to the 4th power plus 2. Then wherever I see x, I will replace it with negative 2. So I have negative 3, so times negative 2 to the power of 4 plus 2. So 5 divided by, so negative 3 times, since I have an even number, at the power, so the negative will go away. So then I'm just dealing with 2 to the power of 4. So 2 to the power of 4 is 2 times 2, which is 4, times 2, which is 8, times 2 is 16, plus 2. So this is just 5 divided by, so negative 3 times 16 is negative 48 plus 2. So 5 divided by negative 48 plus 2 is negative 46. And again, since in math we don't like to see negative signs at the denominator, so I'm just going to multiply both sides by negative 1 so I can get rid of it. So negative 1 times 5 divided by negative 1 times negative 46. So basically this is what I did. I multiplied up and down by negative 1. So negative 1 times 5 is just negative 5. Negative 1 times negative 46 is 46 because negative times negative is plus. Sorry, 46. So again, the strategy here, basically to find the limit, you just plug in the number instead of in the place of x, and you just solve. So if it gives you a nice number, then there's nothing to be done. Obviously, if it's something that does not make sense mathematically, then you have to do something else, and that's something we'll see in other videos. So That was it for this video, and for more videos you can go to Engineering Simple. Thank you and have a great day.